Dun dun dun! Everyone's favorite, inferential stats. So let's have a look. They should have their descriptive statistics, their graph, everything in a table, and now they're going to see if they can accept or reject their null hypothesis. Might just recap with a Kahoot to see how well they know what they need to do for their IA. But they should have, and this is, for me, an order of importance really, based on the limited time that we have. I want them to have done their test, right? That's the most straightforward thing. The more tricky thing is to actually have an accurate written summary of findings. Very few students can get this right the first time because they don't really have an understanding of what they're writing, and so that's what we're working towards, and that takes a couple of drafts. Finally, we want them to understand why we conduct inferential statistics, and I don't think most students leave the IA process with an understanding of this. At least mine don't anyway. And I'll take responsibility. Maybe I'm a bad teacher, but also, you know, we've got limited time and a lot to do. You know, it could be a whole course in itself. Quick introduction, there's a link in the unit plan with maybe about an 8-minute video where I sort of try to explain inferential statistics using the example and what the purpose is, what we're measuring. There's also the reading in the handouts as well. But this activity, I hope, might just provide a little bit more understanding so we can learn through doing. And what we do here is we randomly divide the class. January to June birth dates go to one side of the classroom, July, December on the other. And I actually physically separate them. Now they play this game. This is the T-Rex game. This is the one where if your internet's not working or Google and you hit the space bar and the T-Rex jumps up and down. Anyway, you can click the link and see it. And then once they finish, they can write their scores. So if they're born in this year, we write the scores. Here, they write the scores. Anyone fast finishing can read ahead. Then we find out the averages. Now there's going to be a difference, right? The chance of I mean, only if you've got 2 students, but the chance of that the average is going to be exactly identical is super slim. So you're going to have a difference here. And then what we're going to sneakily do is have a retrospective hypothesis. So while students are writing up their results and we calculate it, I pause the screen, fast forward on my own computer to this screen, and I just write in here my hypothesis was, and I write down whichever group turned out to have the bigger answer. I pretend like I knew that all along, right? Yeah, January to June, they had higher, right? I predicted that being born in January to June would make you better at that game. That was my hypothesis. Then we get the students, give them the traffic lights and say, do you think when you were born would have an effect? Now, realistically, theoretically, they all should be red. Like, there's no way that when you were born has an effect. You're going to find students, though, are going to have orange and maybe a green, because when they want to prove themselves right, because they guess that, you know, they come up with amazing sorts of critical thinking. If only they did that in other studies, that would be great. But anyway, I would hear them out. What are their explanations for why that would matter? And you get some amazing answers, possibly. But it shouldn't. That should just be random. So then we talk about inferential statistics. Were the results because of the independent variable? Was when you were born have an effect on the T-Rex game? Or was that difference just because of luck? Right? And that's essentially what we're testing with inferential statistics. Was it just random? Right? And then we go into this calculator and we see, did it really have an effect, or were the results random? So we can use a calculator. It will take you there, and we'll unplug the data and see what it says. Right, and then if it comes out that they actually are statistically significant, it can lead to a good discussion about the importance of retest reliability. Hey, maybe do the test again, see if it works, but it's going to cut into your time, so that wouldn't work. But yeah, we can say, look, would we really trust the results? How confident would you be in saying that? But I doubt they're going to be statistically significant. Oh, sorry. If they are, again, it can talk about sample size, right? The importance of having large samples. Right. So the brief introduction. Again, there's a video here on the YouTube channel that's linked in the unit plan that explains it all. But we're looking at significance, and here's the technical definition, right? The probability we would get our observed results if the null hypothesis was true. That's what we're calculating. All right. So our null hypothesis for the birth date and T-Rex would be that there is no effect, right, on your ability to play the T-Rex game. And so what would be the likelihood we'd get if we had one group with higher scores? What would be the likelihood we'd see our class have a group with higher scores if our null was true? So if we're Jan to June, what's the likelihood that they would have a higher score if we're saying that actually there is no, if the null hypothesis was true, that there was no, there is no effect there, right? So let's say there's a 20% chance that that group's going to be higher and our null is still true. Well, that's pretty high, so our results are very insignificant. And then we talk about anything over 5% in social sciences. All right, and then we talk about the p-value. We can explain the p-value, that we're looking for a p-value should be under 0.05 in order to have a statistically significant result. All right, that's a decimal version of the 5%. Students then can go into the textbook and use information in the textbook to figure out what tests they're conducting and run through the online calculators and do that, and do their test and write the notes in the workbook. And then hopefully this is what they'll have at the end. So they'll have their results, and they'll have an accurate written summary of their findings, and an understanding of why we conduct inferential statistics. This final one I'm going to assess in an entry ticket in the next lesson, right? But this one, these two here, I can see in their workbook written summaries. So the next lesson we get into writing the report, and so because the deadline's come out, we just want to remind them about that, right? And so they should be keeping up with their notes. So that's the end of the analysis, and then so by now students should have done everything they need to do for the IA, and we're just getting into the writing the final report, and that will happen over 5 lessons.